Now we're going to do a few examples of capacitance values that might be written on the capacitors, figuring out what that corresponds to, and then also thinking about what type of capacitor we might use in each circumstance. So the first example here has a capacitance value that it reads as 223. And we have to recognize, first of all, that that's going to be a 3-digit number, and so therefore the first 2 digits, we see 223. That's going to mean we take the 2, that's going to now be the first 2 numbers in the capacitance. And then that third number, 3, that means that I need to add 3 zeros onto the end of that number. And that's going to correspond to a number that's in picofarads. And that, of course, would be 22,000 picofarads is the same thing as 22 nanofarads. And that would be the correct answer if you were asked to provide it in engineering notation, or if you wanted to give it as a microfarad, it would be 0.022 microfarad. But probably I think 22 nanofarads is the best answer there. What will be the markings on a 0.25 microfarad capacitor? Okay, well, 0.25 microfarad, that's going to be 250 nanofarad, and that's going to be 250,000 picofarad. I see that the 25, that's going to be the first 2 digits, and then how many zeros are there? There are 4 zeros, and so therefore this is going to correspond to 254. That'll be the reading that is on the outside of a capacitor that is 1/4 of a microfarad. What is the capacitance of a capacitor marked as 47? Well, because there are only 2 digits in that number, we know that 47 is just going to be the capacitance, and that's going to be in picofarads. So that's about as easy as the answers get. What type of capacitor is probably being described in Part C? Well, Part C is a 47 picofarad capacitor. That's almost certainly going to be a ceramic disc capacitor, because really those are going to be the capacitors you're going to be working with when you're down at the very smallest levels of capacitance. So I would say that would be ceramic disc. It's possible that you could have a silver mica capacitor that small, but very unlikely, essentially impossible, that it would be an electrolytic capacitor, for example. Capacitor is marked as 103Z. It sounds like a radio station, but it's a capacitor marking. What is the largest possible value this capacitor could be according to the manufacturer? Okay, well, let's figure out what the nominal value is. 103 means that we're going to take the 10 from the 10, and then 3 means add 3 more zeros onto the end, and that's going to be 10,000 picofarads, which is 10 nanofarads. But Z means that we could have a number that is as much as 80% higher than the nominal value, or as much as 20% lower than the nominal value. We were asked for the largest possible value, and so therefore 10 nanofarads times 180% is 10 nanofarads times 1.8, which is 18 nanofarads. Manufacturer doesn't make very many guarantees, but they guarantee that it will be less than or equal to 18 nanofarads in this case.